PowerPoint as well. So for this PowerPoint, we'll take the time of it. We'll be looking at calculating design current and power factor correction and voltage drop. So, starting point for design always starts off with having to work out our design current. These are the two common formulas that we use for this. And this can be in a single phase where we take our power, and that's divided by our voltage to give us our current. It's supposed to be prepared for us. What you want? It's just there on the table. Where Robert. There's another box as well if you want it.
Oh, whose are they?
Rob's.
Right, both boxes?
I think one's his and then one's the one that gets left in it. Possession is 9/10 of the law, isn't it? Okay. There are other formulas that do get used in specific circumstances, such as if you've got a single phase load that has a power factor, we might end up using the cosine in it. But at this level 3, they only look at these two main formulas for you. Okay, does that make sense? Fantastic. Okay, the 3-phase one is the design current, which is IB, is equal to the square root of 3 times by the voltage line, times by the current line, and times by the cosine. Okay, our line voltage, does anyone remember what that might be?
230.
No, that's single phase, that's VP. VO is 400 volts. Okay, that's why we've got the square root of 3 in there to work on it off of that. Okay, if memory serves me right. It's been a long day, I can't think. So, the size of cable that we use in an installation depends upon many things. Okay, the rating of the cable has the cable rating of a cable under defined installation conditions. We have to take into account the maximum permitted voltage drop, and we can use Appendix 4 to calculate this out, as well as satisfying the F-volt loop impedance from table 41.2, 41.3 and 41.4. Okay, does that all make sense so far? Yes? You hate that comment, don't you? It's a force of habit for me. Okay? So, the factors that influence the current carrying capacity of the cable are things such as our design current. Our cable must be able to carry the full design current of the circuit. Okay? The type of cable that we use, if we're using PVC, MIMS, copper conductors, aluminium conductors, buzz bars, all of these different things, they all have different current carrying capacities. So we have to make sure we're selecting the right cable for the right job that we're doing. Okay? All happy with that? The installation conditions, how are we fitting this around the room? Okay? The environment that's being fitted in, are we going to be clipping it direct? Most domestic situations we use the 100 methods because it's twin and earth, and they are examples such as fitted above a plasterboard ceiling, above a plasterboard ceiling with insulation, fitted in a thermal insulated wall, okay? And then we come down to reference method C, which is clip direct. Reference method A, enclosed in conduit in a wall, okay? These are the common reference methods that we use, okay? Different reference methods will have a different effect on the cable, won't it? What's the effect if I run that cable in a wall with thermal insulation on it? What's going to happen to that cable? It's going to get hot, isn't it? Okay. It's going to be able to carry less current. So when we're actually looking at Appendix 4 and the current carrying capacity, you'll see that they differ depending on the environment it's running. Okay. The surrounding temperature. Okay. Air temperature will have an effect on the cable's resistance, so we take that into account as we design the cable. Okay. The ambient temperature, the ambient ground temperature, these are the two common temperatures that we use. Okay. The type and size of the protective protection and how long the cable has to carry the fault cone for. So there is a correction factor purely for the protective devices. If we are using a fuse wire system, we have to make sure that the cable is able to carry an extra 25% of the current. Okay? The reason for that is because the fuse wire inside there takes longer to blow. All the other protection devices, we're happy that they'll disconnect in time, but for the old fuse wire systems, if you ever have to design one, we have to include that correction factor. I think it's 0.725 is the full factor that we apply for that. Okay. So, in order to get the relationship correct, we start off with our IB. So our IB is our design current. Okay. The next step for us is looking at our IN. The IN is the nominal rating of our protected device. So if I had a design current of 5 amps, what size protected device would I select from that?
6. 3.
6. It's got to go up. Equal to or greater than. Okay. Our IZ is the tabulated current carrying capacity of the cable. Okay, this is looking at now we select the cable. So we then have to make sure that the cable is able to carry either the same amount of current as the rating of our protected device or more. Okay? Does that make sense? Okay. And we also have IT, which has to be greater than IZ. IT is the calculation that we can carry out. Okay. Is everyone happy with this relationship? No one want a divorce yet? Okay. IT being the tabulated current carrying capacity. Okay. If I am going too fast, do say I will slow down a bit. It is pretty much the same as what we did last year, except we're going to look at some more factors this year. Okay. So our actual cable process is, we start off with the design current for the circuit. We then go on to select our protection device. Okay. We then look at the various correction factors. What sort of correction factors can you remember from last year?
Grouping.
Grouping? Okay.
Ambient temperatures.
Ambient temperatures?
How it's installed.
Yeah.
Trunking.
A bit more detail than how it's installed. Trunking isn't a correction factor for us, I'm afraid.
Insulation.
Flue direct.
Insulation, yeah, we've got CI, which is insulation. That's a reference method.
If it's like singles or something like
No, not going down the wrong sort of lines now. You're looking at environmental factors. Okay.
if it's going from mobile then.
It's going inside out as well.
Special locations like a sauna.
You'll see what I mean in a minute when we get onto the list of them. Okay. We determine our installation methods next. Okay. So this is where we take into account if it's in the conduit or trunking, if it's clipped direct, if it's inside outside. Okay. And from that we can then look at the current carrying capacity tables in Appendix 4 in the big book. You can use Appendix F in the on-site guide if you want, but Appendix F only takes into account, I think it's 5 cables. Whereas in the big book it takes into account SWAs, single core SWAs, so it's got a larger variety of cables. Okay. So the correction factors. These start off in Appendix 4, and these are a few of the common ones. CA being for our ambient temperature. This can be found in tables 4B1 and 4B2 in Appendix 4. It can also be found in Appendix F as well. Okay. CC is looking at the circuits buried directly in the ground. If you want to see these tables, they are located on
373.